7th grade. So our learning target today, we have a couple learning targets. First of all, we're going to talk about how I can identify or how I can define rational and irrational numbers. And first of all, we have to understand what a rational and irrational is to move on after that. But then we will order the rational numbers, only the rational numbers on the number line. So we're going to sort through what are rational and irrational, and then we're going to just take the rationals and order them on a number line. You should be on page 1. So what is a rational number? And rational number, really by definition, is a number that can be written as a ratio or a quotient. Now, quotient just means division. A fancy way to say all of that is rational number, but rational numbers are really just fractions. You just got to remember that's a fraction, or it can be manipulated into a fraction. So everything we're doing is fraction work. And if you can remember it this way, that a rational number really comes from the word ratio. Ratio is a fraction. So a rational number is a ratio or a fraction. All right, so steps for ordering rational numbers. The first thing that we're going to do when we order rational numbers is we're going to convert all fractions to decimals. All fractions to decimal. Then step 2 is that all decimals need some place value. So we have to think about tenths, hundredths, thousandths, and so on, the place value, just like you did in elementary school. And then third, we're going to just order them. We're going to think all of these in terms of money. Go ahead and copy those if that's too fast. Okay, so if I'm going too fast right now, you're going to need to stop that video. Otherwise, we're going to move on. Okay, so we have these 5 rational numbers. Again, all of these are considered rational because they can be turned into a fraction. They don't all look like fractions from the start, but they can be turned into a fraction. According to our directions here, we're going to convert all fractions from a fraction to a decimal and identify place value. So part A really turns into 50 cents because we're going to think all of these in terms of money in the bank. Okay, the second one's already ready to go. This one's okay because it's already 1.25. So that one's fine. $1.25. C, you can put that in your calculator. We're going to attach that negative to the numerator, and that becomes negative 0.33. Go ahead and copy that down. All right, and then part D, we have 50 cents. 50, positive 50 cents. In part B, we have negative 5 attached to the top is negative 1.66. Negative 1.6, so like owing somebody $1.66. Our job now is just to put them in order from least to greatest. Now, when you're thinking of least, you're thinking of the worst bank situation to the best bank situation. Okay, so the worst bank situation out there right now in this set of numbers would be this one, negative 1.66. So we're going to go ahead and say the worst situation is negative 1.66, which is E. And then I've already kind of put them in order, you can see on the right-hand side, but we'll gradually work through that. And my eyeballs are looking for the next one. Negative 50 cents is the next. And then owing somebody 33 cents would be the next worst situation, which is letter C. Again, if I'm going too fast, pause the video. And now we're working in the positive range after that. So 50 cents would be the next best value, 50 cents. And finally, $1.25. So that would be the order of E, A, C, D, B, from worst scenario to best scenario. So our job now is to order these on a number line. You'll think of these as money. It might help if you put little zeros in here and think of negative $1.50, negative 50, positive 50, and $1.50. We're going to just drop the letters in on the proper location. So negative $1.66 would be somewhere around there. Somewhere around there. Why? Well, that's negative $2, and this would be then a negative $1.75, that red line here. So negative 166 would sit somewhere in between those. All right, so then we're going to go negative 50 cents. Pretty easy to see negative 50 cents there. It's kind of right on that nice line. And then we have negative 33 cents. I'm going to estimate that to be about right there. Why would I say that? Because this line right here is approximately at negative 25 cents. All right. And then we're going to go into the positive range, which is positive 50 cents. And then finally we have $1.25. Now that's a really easy one to see because it lands right on this nice line there. So $1.25. So that's how we would order rational numbers. Again, rational numbers come from the word ratio. Ratio just means a fraction. All right, guys, let's take a look at this next example. So we're going to do first is convert them all to decimals. Some of them are already in decimal form. And then we are going to number them on the number line. Okay, here we go. So the first one is -7/4. We're going to attach the negative to the numerator. And in your calculator, you can just put -7 divided by 4. When you put -7 divided by 4, you end up getting -1.75. The next one's 1.1, so you get 1.1, and we're going to add a 0 there, 0. That's B. All right, let's keep moving on. Then we have 1 divided by 2. Most kids can do that in their head. If you can't, that's fine. But we have 1 divided by 2 in your calculator if you need to. That gives me 50 cents for C. 50 cents. All right, I'm kind of running out of space there because I'm using this pen from the tablet. You might have more room than I do. We're going to attach that negative to the top, which is -1/10. -1/10 looks like this. You can put that in your calculator if that's not something that you're super great at. I'm going to represent that in terms of money, which is -10 cents. And the last one, part E, then, is -1.3, but I want it to be in terms of money, is -$1.30. Worst scenario to best scenario. So we're going to go from the worst scenario to the best scenario, and I'm just going to go ahead and list those numbers. So the worst possible scenario out of all this bank situation, I would have to say, is A, -$1.75. So we're going to go ahead and say A is the worst, -$1.75. The next worst possible situation should be, it looks like E would be the next, this one here, -1.3, E. All right, moving on. What's the next worst situation? Well, it looks like we have +110, +50, and a -10 cents. So -10 cents would be next, which is D. All right. And then moving on from there, then we are in the positive range, which is C, which is 50 cents. And then the last possible one would be $1.10, which is letter B. So we're going to just drop those letters in order from least to greatest. So the worst possible scenario was A, $1.75, which would be about right here. Thinking about that, that's $1.50. E would be about right here, because this right here is -$1.25. D, if you think about it as -10 cents, would be somewhere in this range, D. C is +50 cents. Now we're in the positive range, so we're going to drop that there, C. Again, if I'm going too fast, go ahead and pause the video. And finally, B is $1.10, which would be right here. So we have A, E, D, C, B. That's ordering rational numbers on a number line. All right, guys. So we're going to keep moving on here. All right, so on page 2 then, page 2, there's a you try number 2 there. I'm going to have you go ahead and pause the video at this time and you try it. Everybody should be pausing the video right now so that you can try this first example, you try 2. But I'm going to keep plugging through because you should pause it, take some time to solve, and then see how I did. So I'm going to convert to a decimal. Should be, just checking your work now because you should have paused the video and taken some time to solve here. Is 25 cents. This is $2.50 if I add a 0. This is 75 cents. I'm going to add a 0 here. And this is 30 cents. Again, that shouldn't be too fast if you actually did pause that video when you were supposed to. Okay, as I work from left to right, then I have D value is -1.70. Then I have the E value is -0.3. Okay, so then the next value that I have there would be the A value. We're looking at the fraction -1/4, which is really like -25 cents. And then we have the C value, which is 3/4 or 75 cents. Okay, guys, and then the last one would be what should be the letter B, and it should be the best situation, which for sure is 2.5. Now you can add a 0 there and think of it as $2.50. I know it's a little messy there, but you should be just checking your answers at this point. So the D value then would be right about here. negative $1.70. The E value would be negative 130. The A value would be negative 25 cents. So the C value is 75 cents, which should sit about right there because this is 50 cents. And finally, the B value should be $2.50, which actually ends up being off the graph. Sorry about that. Just realized that. So you should have D, E, A, C, B in order from least to greatest. So that's how we order rational numbers from least to greatest. Okay, guys, so let's move on. If that was too fast, you'll have to stop and go back, but we're moving on. Terminating. To terminate is a decimal that stops or ends. If you think about the terminator, what happens to the terminator? We kill, stop, end. Terminating decimals. They are very short decimals. They stop or end. All of these are terminating decimals. They are rational. They come from the word ratio, which means they all can be turned into fractions. That's what rational numbers do. All right. Repeating decimal. A repeating decimal is a decimal that has a pattern to it. It's that little bar notation that you've seen before. You should have seen this in elementary school, how we write repeating decimals. It's that little bar that's above there that says that the 3 is repeating on that one, and down here the 15 is repeating. So all repeating and terminating decimals are example of ratios or rational numbers. All terminating, all repeating. So how do we write rational numbers as decimals? Step 1, if there's a whole number, leave it. If we have a whole number, we just simply leave it. If you can continue to work on then at that point, you would want to convert the rational number, which is a fraction, to a decimal. So if there's a whole number, leave it. Take the fraction to convert to a decimal. You can use your calculator to help you through these steps. All right, so in this first example, we have this integer of -2. Leave it. Decimal point. Decimals separate parts and wholes. We're separating now. We're going to deal with the part. The part is the fraction 1/4. Put that in your calculator. Some of you can do that in your head. The fraction 1/4 really is just 0.25. So it becomes -2.25. Everybody write that down. Make sure you're in good shape for that. -2.25. The question is that a terminating decimal or a repeating decimal? You should have said that that's a terminating decimal. We'll give that a T. All right, guys, over here. In this problem here, we don't have any whole dollars or whole values. So we're just going to go ahead and put 5 divided by 11 in our calculator. And we do that, we get 45. 4 and 5 are both repeating. 4, 5, 4, 5, 4, 5. Now, you'll notice that it's been rounded kind of at the end. That's just because the calculator ran out of room. We're going to ignore that. Because there's a pattern there, we're going to say that that's a repeating decimal with a pattern. All right, next example, we're going to take that negative and attach it to the numerator. We have -3 divided by 11. -3 divided by 11. We end up with -0.27. The 27 is repeating the whole time. 27, 27, 27. Again, you might have a rounding thing happening at the end there, and that's just because the calculator ran out of room. Because there's a pattern there, we're going to go ahead and call that a repeating decimal. We'll give that the letter R. Next example now, we have this whole number -7. We have a decimal point separating the wholes and the parts. It's really an integer there. And then we have this fraction 3a. So we're going to put 3 divided by 8 in our calculator. Just type in 3 divided by 8. And what should come up in your calculator screen is 0.375. Now, I'm not putting 0 down because really that's a -7 in that spot. And that is a decimal that stops or terminates. We're going to give that a T. In the next example, then, we have a negative attached to the top. We have -6 divided by 5, which gives us -1.2. Now, that is a decimal that stops, so we're going to say that's terminating. To terminate means to stop. Okay, guys, the next example, we have a whole number 1, and now we're going to deal with the part. So that was the whole. Decimal separates. The part is the fraction 5 divided by 27. Go ahead and type that in your calculator. 5 divided by 27. It should be a repeating decimal. The decimal that repeats there is 185. All of that repeats, so that's 1.185. That's a repeating decimal. All right, guys, the next example there, we have a whole number 4. Lock in that decimal. The fraction 3/16. 3 divided by 16 gives us 1.875. Everybody go ahead and type that in. 3 divided by 16. Make sure you're getting 1.875. That is a decimal that stops. So we're going to say terminate. To terminate. All right, next example there, we have a -3 separating. So go ahead and write down -3 with a decimal point. Now we're going to deal with that fraction 4/9. 4/9 is a decimal that repeats 4, 4, 4, 4, 4 to infinity. So we're going to put a 4 with a bar over the top. And because there's a pattern there, we're going to go ahead and say that that is a repeating decimal. All right, guys, so our last topic then is going to be how do we write decimals as fractions? And then we'll make sure that we can sort out rational and irrational numbers. So how do we write decimals on fractions? You should be on page 3. First, you have to find the place value, thinking of it in terms of money. Okay, hopefully you're caught up. If not, then you'll need to pause that video. Okay, and step 2 then. For step 2, we're going to keep the numbers as your numerator. So we find the place value, that's your denominator. And then we're going to keep the numbers as your numerator. Step 3, simplify. Okay, so let's give it a shot. Well, there's a negative out front. We're going to find the place value. The place value here is tenths in the 2, where the 2 is, and hundredths, where the 6 is. We're going to use the furthest place value. So the 6 is the number that's furthest to the right. That's our place value then. The 6 is in the hundredth spot. So our denominator becomes the one that's furthest to the right, which the place value is hundredths. And then we go ahead and just ignore all of that front end stuff. We ignore it all. I'm going to cross off just for a second so you can kind of see what I mean. That becomes 26 hundredths. Now, because it was negative, it becomes negative 26 hundredths. It says to put in simplest form, but we're not going to worry about that for this moment. We're just going to first get the place value correct. Just as a side note, for those of you that are ready to handle that, we could divide top by 2 because it's even and bottom by 2, and you get negative 13/50ths. But I don't want us to stress about that right now for simplest form. Okay, here we go, 7th grade. Let's finish this up. So now, this is -3 is the whole number. That's our whole number. Our part comes in here. We're going to deal with the fraction now, or the part, the 0.1. What place is that in? Tenths. How many? 1 in the tenths place. There's a number 1 in the tenths place. Answer is the mixed number -3 and 1/10. 1/10. All right, couple left here now. So try this as a fraction or a mixed number. So this first example here, we don't have any wholes. There's 0 there, so it's just a fraction. We have tenths, hundredths, thousandths. We take the place value of the thing furthest to the right. Furthest to the right, we have the thousandths place. And then we're going to go ahead and cross all this off in our brain, and we're going to say, well, that's 125 thousandths, lowest terms. I'm not going to worry about lowest terms right now because I just don't want you to get confused, but that's our value, 125 thousandths, no whole number. This problem here does not have a whole number either. There's a negative out front. This is the tenths place. So if I go back in and I kind of cross off all of this stuff and say, well, how many tenths? You should be saying -7/10. If I'm going too fast, go ahead and pause that video. Otherwise, we're going to keep rolling. Here we go. We have -10 as the whole number. If we think of our place value, this is the tenths and the hundredths. The 5's in the hundredths place. So we're going to go ahead and ignore all the front end stuff. And we're going to go ahead and grab that, which is 25 hundredths. So our entire answer is -10 and 25 hundredths mixed number. Okay, group. So we're going to keep moving just so we know the difference. Rational or ratio means that it is a fraction. All ratios are fractions. So here's how we're going to break it down. What are rational numbers? Some examples of rational numbers. Rational numbers are nice fractions. So things like repeating, terminating. Go ahead and write. I know it's hard to read. Sorry, I'm using this pen. And when I say nice, I'm just giving you some ideas of what kind of fractions, but really it's all fractions, rational numbers. Nice square roots, rational numbers. Those are the rational numbers. So some examples of rational numbers would be 1/2, because it's a fraction. The square root of 9 works. Why? Because the square root of 9 is the nice whole number 3, and we can make that a fraction. A mixed number, -3 and 1/4, because we can make that a fraction. A decimal, 0.25. Those are all what we call rational. Okay, versus irrational. These are a little bit easier to understand, I think. So sometimes it's easier to figure out if it's irrational or not rational, not a fraction. And it really breaks down to two categories. It's one of two things. It's either pi, because that's a non-repeating, non-terminating decimal, goes to infinity, or icky square roots. So icky square roots mean no pattern, doesn't repeat, and so on. So icky square roots have no pattern, doesn't stop. So I'm going to go ahead and list them. Okay, so the nice square roots are the square root of 1 is nice because it equals 1. So that's rational. Okay, so that doesn't work. The square root of 2, though, does not work nice. When you put that in your calculator, this icky decimal, that is what we call irrational. Okay? The square root of 3 is icky. Put that in your calculator, nasty. The square root of 4, though, is nice. It's equal to 2. That's rational. So if we keep going down this list, you can kind of see what's going on here. Now, they're not all prime numbers. Square root of 5, put that in your calculator, icky. Can't make a square. That has an area of 5. Square root of 6, and now notice that's not a prime number, but you put that in your calculator, it's icky. So that's square root of 7, icky. Square root of 8, again, that's not prime, but it's still an icky one. The square root of 9, though, that's nice. It's 3, rational. So all the ones in green here, I'll go ahead and highlight them, are irrational. Put them in your calculator, get this nasty decimal. That reason why that is when you take a square root, we're really asking, is there a square that has that area? Does there a square that has an area of 3? No, there's a rectangle, but not a square. All right, guys, so our summary for today is this. Rational numbers can be written as fractions. And remember that repeating and terminating decimals are rational. So go ahead and copy those down. Okay, guys, so your homework then for tonight is to do pages 4, 5, and 6. Pages 4, 5, and 6 due tomorrow. Have a fabulous night.